In this example today, we're going to start looking at binary variables. So the Tatum company is considering 7 investments, and cash is required for each investment, and the NPV each investment adds to the firm are listed on the next tab. So each NPV is based on a stream of future revenues, and it includes the cash requirement, which is incurred right away. The company wants to find the investment policy to maximize its total NPV. So let's go over here into the next tab. Up here we can see our inputs. We've got our investments, 1 through 7. They have a cost listed in millions of dollars. We have an NPV listed in millions of dollars. And then we have our decision variables. So in this case, our decision variable is going to be whether or not to invest. So this is a yes-no question. There is no numbers or anything that goes in here, and this is where we're going to be using the binary variable. 1 if yes, 0 if no. And so this is where binary variables become really important when dealing with any of these Excel problems that we're dealing with, because this allows us to model logic. And we're going to show you over the next couple of weeks how we can use this to model logic. And so let's get into that. And so the first thing that I want to do is let's go and let's calculate out what our return on investment would be. Let's see, do we want to, yeah, let's do that first. We're not going to really worry about range names yet. So if we go, our return on investment is going to be our NPV minus our cost. And then we will go and we will divide that by our cost. So simple finance formula, 12% return on investment for investment 1. And let's go and we'll just drag that all through there. So now we have our different return on investments. Now, one of the things that we do have to begin with is we have, part 1, we have a budget of $15 million. So let's go and do this 2 different ways. First way is our greedy heuristic method. And so what does that mean? We're just going to, actually we're going to spell it right. It's S-T-I-C, let me see. Yeah. So what is this? Oh, this one is just most bang for the buck. So we're just going to keep picking out the best return on investments until we are all finished. And so how are we going to do that? We're going to kind of do it by hand. So Control B, I just want to make that part big. And so we are going to calculate out and what we're going to invest with. So what I want to do is let's put some range names in. I want these 2, so data, always do that. Oh, formulas, create from selection, so we'll tote those 2. Let's get total cost, we'll get budget. We're going to grab number of projects and min number of projects, even though we're not going to use those right now. So we'll create from selection. Oh, I kind of put that in as 2. It's not going to work. So we'll go back, select all 4 of these again, create from selection, top row, good to go. And then this one here we'll just call invest. Question mark. Okay, so this is our, once again, this is our decision variable. If we put a 1 in, we're going to invest. If we put a 0 in, we are not going to invest. And once again, we don't have to put in a 0 because it'll just recognize it. And so I know I want my budget has to be less than or equal to $15 million. So the way that we're going to do that, it's an easy sum product equation, where we're going to take our investment and we're going to sum product it with the cost. Okay, so now I have the basics of it set up. So now let's figure out which projects we're going to invest in, and we're going to go for the biggest number first, which would be project 4. So I'll put a 1 in there, and so it's calculating for me. I'm not using solver on this. I am only looking at my biggest percentage gainers. And so after number 4, we look, number 6 would be next. Put it in there. It puts us up to 10 million, so we got some room left. And so the next one would be 2. We put that in. We're up to $12.8 million. Can we fit anything else in? Let's see, if I go to 7 and fit that in, no, 7 was the cheapest one. So we have our greedy heuristic method, which tells us we picked the highest return on investment and then continue adding until we got done. And so that tells me I need to invest in projects. That's 2, 4, and 6. Okay, so 2, 4, and 6 have a total cost. And their total cost is we will just Control C to copy that over. We're going to paste special as just a value. So that kind of gets rid of any of the connections to the equation that we got there. And let's see. Our NPV, we will just sum up our NPV of 2, and then Control 4 and Control 6. So our NPV is $14.6 million. And so our return on investment for that will be this 14 minus the 12 divided by the 12. And let's turn that into a percentage. So that gives us 14.1% return on investment by just going and doing everything straight out. Okay, so that's not bad. Now let's actually use solver. So we want to, because we want to maximize the NPV, and let's, so we're going to do the optimal solution. And this is going to be with our budget constraint only. Alright, so we've got this all set up. We're just going to plop right into solver. So data solver. And actually, we can't do that yet because I have not stated our objective function yet. So we're going to need to do that. So we're going to come down here and we will sum product the NPV with our investing decisions. So 14.6. I probably could have just, if I would have thought about it, I could have just had this already set up and then we could have filled it in over here, but different ways to do different things. Okay, so now let's go into solver. Going into solver, set objective. We want to set that NPV, which, let's give it a range name because I want that to show up in solver. I forgot to do that before, so formulas, create from selection, left column. Come over here, Control B, range names. Let's just get those on the page. Use in formula, paste names, paste list, and there we go. Now we'll go into solver. So back to data, going into solver. Our objective is we want to maximize our NPV. So max, we want to change by this decision variable. And we do have a constraint of our total cost has to be less than or equal to our budget. We want it to be non-negative. We're good to go. I hit solve, and it found a solution, but it's not what I was expecting. Why? Because, well, I didn't tell Excel that this has to be a binary variable. I didn't even tell it has to be an integer. So Excel goes, okay, well, the best thing I can do is get 2.5 for da-da-da of investment for, and that'll maximize everything, which should make sense. It is the highest return on investment, but this is not the solution that we're looking for. So we need to go back and actually plug in a binary variable now. So I want to add my investment. So I'm going to come over here, instead of the greater than equal to, I'll click on that, I'll bring it down to B, I will add a binary constraint, say OK. I'm going to cancel it because when I said add, it dropped it in and brought the new list up. So here I go. Now I have a binary constraint in there, so we're modeling that logic. It's going to be either a 1 or 0. It's going to turn on or off. I'll hit solve. And there we go. I hit OK. I do have now binary objects in there. Now notice this is a different mix than the one that I picked before. So let's Control C. I'm going to copy this down, so Control V. And this is telling me to do 3, 5, and 6. So I'm just going to change these numbers here. 3, 5, and 6. And Control C, Control V. So my total cost on that is going to be, we'll do a sum, make this easy on ourselves. We're going to go sum product. We'll do the binary and the cost. Now I'm going to Control C and right click on here and paste values because I don't want that formula changing on me. So my cost is higher, but my NPV is also going to be higher. So we're just going to do Control C, come over here, right click and paste values so I can hold on to it. You can see my return on investment is down to 12.1%, but my NPV is much higher at 16.7 by choosing those different projects. So before we just went highest ROI down the line. Here, because we have that constraint in on the budget, it tried to move things around to maximize that NPV and use up all of this constraint. We still have a little bit of money left, so I don't know. Maybe somebody's going to get a bonus for putting this together. So that's the first thing that we have. Let's bold that too. So in the next video, I'm going to show you how we can model other logic in the decisions about all these other projects that we can do.